Good morning, everybody. Welcome to the Westminster School Department of Chemistry, and this is Miss Wagma Shahab. So, today we are going to learn the carbonate industry, and one of the important component of carbonate industry is limestone. I hope everybody has watched the flip video that I had sent 2 days back. So I will ask everybody to form their own groups. You know about your groups, right? In your groups, discuss about what have you watched in the flipped video and join the Padlet wall. Join this Padlet wall and write down the answers to the following questions. These questions can be answered on the basis of the flipped video. So I'm giving you 2 minutes to write down your answers. Please pause this video for 2 minutes. Now, I hope everybody has written their answers in the Padlet wall. Now let's start with the introduction of limestone. But before that, you need to understand some important vocabulary. Calcium carbonate is commonly known as limestone. Calcium carbonate chemical formula is CaCO3. Calcium oxide, it is commonly known as lime or quicklime, and its chemical formula is CaO. Calcium hydroxide is commonly known as slaked lime in the solid state, and its chemical formula is CaOH whole twice. You need to know these chemical names for this lesson. I want everybody to write down this vocabulary in their notebooks. Okay. Now, my question is, do you know what is the test that we usually do for carbon dioxide? How can you find out the presence of carbon dioxide? Yes, of course, we do the lime water test. If you take lime water and pass carbon dioxide through it, it will turn milky. Now, lime water turns milky with carbon dioxide because when carbon dioxide reacts with lime water, it forms insoluble calcium carbonate. And calcium carbonate is a white solid. It's commonly called as limestone. Limestone is basically a sedimentary rock which has a very high percentage of calcium carbonate. That's why we say that limestone is actually calcium carbonate. Now, for this lesson, our objectives are to explain the stability of metal carbonates and to describe the manufacture of lime from calcium carbonate in terms of thermal decomposition. My dear students, why do we need to find out the stability of metal carbonates? Because the term metal itself means that a number of metals can form carbonates. So we need to find out which metal carbonate can be thermally stable and which metal carbonate will be thermally less stable. Because this stability will later tells us about which one will form the carbon dioxide easily or which one will decompose with a large amount of heat. Now, first of all, in order to learn the thermal stability of limestone and metal carbonates, we'll first look at the uses of limestone. Why is it important to understand the importance of limestone? Because limestone can be directly used. Limestone, being basic in nature, can be used to neutralize the acidity of soils and lakes. When you add limestone into the soils and lakes, it will neutralize the acid. Indirectly, limestone can be used in the extraction of iron. Same like that, we can see a number of a number of popular buildings and landmarks that are formed with limestone and clay. We know about the great Egyptian pyramids. They are also made up of limestone and clay. So basically, we can say that limestone is a raw material for many important building materials like cement, like concrete, mortar. Okay, now let's come for the stability of metal carbonates. In order to understand the stability of metal carbonates, I'll just tell you how does stability vary from metal to metal. I'm using a paintbrush. For example, we have a metal in the reactivity series as sodium, potassium, calcium, magnesium, and others. According to the reactivity series, the reactivity decreases as you go down the series. Now, if a metal carbonate is formed with a more reactive metal, if a metal carbonate is formed with a more reactive metal, it is more reactive. That metal carbonate will be highly stable and it will not be able to decompose it. Same like that, if a metal carbonate is formed with potassium, potassium is also more reactive or very reactive metal, so the metal carbonate will be very hard to decompose. On the other hand, calcium and magnesium, they are not, as compared to the sodium and potassium, they are less reactive. So calcium carbonate and magnesium carbonate will take less amount of heat to decompose because they are moderately reactive metals. Same like that, the more you go down the group, for example, we reach till copper. Copper being the least reactive metal in the reactivity series, copper is above gold and silver. So copper will take very less time to decompose because it is less reactive metal. We can also say that if a metal carbonate is formed with more reactive metal, if it's a highly reactive metal, I'm sorry for my writing, then it will be more stable, and it will be very hard to decompose it. Okay, now let's check this. We can say that stability will depend on reactivity series. We can say according to this that if you apply heat and you want to thermally decompose a metal carbonate, thermal decomposition means if you want to apply heat and decompose the metal carbonate, then it will require very less amount of heat. Now let's talk about the products. Always remember, whenever a metal carbonate will be heated, whenever a metal carbonate is heated, it will form two products, metal oxide and carbon dioxide. This is a common equation. Now let's take example of calcium carbonate. So if calcium carbonate, that is limestone, if it is heated, you will get calcium oxide plus carbon dioxide. If you take copper carbonate, if copper carbonate is heated, you will get copper oxide plus carbon dioxide. What we can see here is carbon dioxide is common in all the reactions, and carbonate is also common, which means if a metal carbonate is heated, it will always form a metal oxide and carbon dioxide. This thermal decomposition can also be used for the manufacture of lime. Lime means calcium oxide. If you want to prepare lime, you will need to thermally decompose calcium carbonate. So when we apply heat to calcium carbonate, we'll get metal oxide, that is lime, along with carbon dioxide. So this is a solid, this is a solid, and carbon dioxide will be produced in the form of a gas. Now, if you look at the reactivity series, it also says the same. Please read this slide for some time and try to make yourself understand what does it mean. What will happen if a most reactive element will form a carbonate? What will happen if the reactivity goes down, and what kind of stability will be there in the reactivity series? Okay. Now I'm giving you a small task. Please pause this video for 3 minutes and arrange the given metal carbonates in decreasing order of their thermal decomposition stability. Like which of this metal carbonate will be the hardest to decompose? Which one will be less? And in order of that, you will rank which one will be the one which can be easily decomposed by applying heat. So pause the lesson for 3 minutes and think. I hope everybody's done with their task. According after this is how we can prepare lime, and this is exactly you can heat calcium carbonate and you will get calcium oxide and carbon dioxide. Now, what do you know about this? If you look at this, we have started a limestone cycle. We started with limestone and it is converted into calcium oxide, that is quicklime. By heating this, you get quicklime. How can you get slaked lime? Now, remember, when we add calcium oxide, that is lime, into water, you will get slaked lime, that is calcium hydroxide in the solid state. And this process is called as slaking. This slaked lime, if you add more water into it, it will turn into lime water, which is aqueous solution of slaked lime. And the same lime water, when you pass carbon dioxide through it, it will turn into calcium carbonate. So this is all about how we can form a limestone cycle. We can also say that calcium carbonate, if you heat it, you will get calcium oxide. Calcium oxide, if you add water, you will get calcium hydroxide. This calcium hydroxide, if you add more water, you will get lime water. And this lime water, when you pass carbon dioxide, again you will get calcium carbonate. So this is all about limestone cycle. Now I'm giving you your task. Please pause the slide for 10 minutes and do the task. Welcome back, students. I hope you all will be done with your task, and I want everybody to post their tasks into the assignments through Teams. You can also submit it through OneNote notebook, or you can submit your task through assignments that I have already uploaded. Now, in this cycle, if you see, you'll find that it has some blanks. Pause this video and complete ABC. I hope everybody's done. Now it's time to check our knowledge. Please click on this link and join this quiz. I will be able to see your score by the end of the lesson. Thank you so much everybody for doing the plenary. I'll definitely get your results. I want everybody to go and check your homework in the Teams and submit it according to the due date. Till then, Bye bye and have a good day.